Hey guys, welcome to the first lesson in Unit 5. And this lesson is going to feel very algebra-like to you. And this unit has a lot of mixture of maybe some algebra and some geometry all mixed together. So I want you to look at these following problems, and I want you to think about if you're in algebra, how you would factor these. So get away from the trig, think more algebra here. So I'll go ahead and do the first one for you. So this is purely algebra, and this is what we're going to see in trig. So it's very ones of my so these are conjugates of each other. So I want you to start with the algebra and see how you can transfer it to the trig. Okay, so I'm going to slowly scroll through this and show you my answers on all of these. And so the goal is to like move away from the algebra side and feel more comfortable with just factoring the trig side as is, just knowing that like for instance on this one, when I see this, I'm thinking that algebra equation in my head when I factor it. Okay, so let's keep going. And again, push pause. I'm not spending a lot of time on each one of these, but push pause and look at my work on each one of them if you're having some issues. Like for instance, this one, that is one of the sum and difference of cubes. So you might need to kind of review that. You might need to review like factoring when there's something other than a 1 in front of the x squared. So different things like that, pay really close attention to. This is an x to the fourth, so I broke it down once, and then this is also a perfect square binomial, so I had to break that down again. Same thing with over here. So again, I mean, part of this too is we're kind of reviewing that algebra part of it as well. Okay, so for this next part, I want you to think about the Pythagorean theorem. And so in geometry, you start out with a squared plus b squared equals c squared. And then earlier on in trig, we applied it to, you know, the coordinate plane and the circle. So x squared plus y squared equals r squared. Okay, so then a couple units ago, we talked about in the unit circle how x squared was representative of cosine and y squared, or y was representative of sine. So think about cosine squared of whatever your angle is plus sine squared of whatever your angle is equals radius squared. Well, radius squared in a unit circle, or the radius is 1, so the radius squared would be 1. So this is our basic Pythagorean identity that we are going to use over and over again. We call this the mama identity because she has some babies that kind of spring off of that. Okay, so a lot of these things that we're going to do stems from this. And so I want to start off with two basic things. And again, think algebra. So if this is our identity that we're dealing with, and we have to solve these equations, see if you can figure out the answer to these two. Okay, so you should see manipulating this identity that 1 minus sine squared theta is cosine squared theta, and cosine squared theta, sorry, minus 1 is negative sine squared theta. So we're just moving those around just like we would an algebraic problem. Okay, so we are going to take this basic identity right here, and we're going to divide it by the cosine squared theta. So what we're doing is we're turning this into a 1. So let's see what happens. Okay, so when we do this, this becomes 1 sine squared theta over cosine squared theta. That is tangent squared theta. And 1 over cosine squared theta is secant squared theta. So this is our first baby identity. Okay, we're going to do the same thing, except now dividing by cosine squared theta, we're going to divide by sine squared theta. Okay, so when we do this, this becomes cotangent squared theta. This becomes 1, and this becomes cosecant squared theta. So this is the second baby. And we are going to use these three identities all the time. They're pretty popular. Okay, we're going to also talk about another set of identities. So we've talked about the Pythagorean identities. Now we're going to talk about negative angle identities. And this has everything to do with all students take calc. So let me go ahead and list them. We're going to start off with theta is going to be a reference angle that's positive and acute. So let me write down all the identities and we'll come back and explain it. Okay, so these are my identities, and I want you to see that when we have a negative angle, we get a negative, like it changes the sign of our answer. So, so it's always the opposite of the regular sine function. So for instance, the sign of positive 30 is 1/2, but the sign of negative 30 is going to be negative 1/2. So this is consistent here and here. But notice with cosine, let's go to nice number. So the cosine of positive 60 is 1/2, and the cosine of negative 60 is also positive 1/2. So this middle section here is going to be positive either way, and this is why. So if we start off with 30 degrees here, and we go down and make it negative 30 degrees. We're in that fourth quadrant. So think about that fourth quadrant, and all students take calc. Everything except for cosine and secant are going to be negative. So that's why it ends up where this middle one, the cosine and secant, are going to be positive both for positive angles and for negative angles. And it works for all other angles as well. Okay, so you might have two problems like this. So for number one, I have sine of negative 60. So I know that it's going to be negative whatever the sine of 60 is. So let's see, the sine of 60 is square root of 3 over 2. So it's going to be negative square root of 3 over 2. The cosine of 45 degrees is square root of 2 over 2. But negative 45 degrees is also going to be positive square root of 2 over 2. So that's the way those work, and these come up a lot as well. But what I was saying about the other angles is, let's pretend like theta is, I don't know, like 135. Okay, so let's talk about sine, because I'm thinking about, because that's in quadrant 2, and sine should be positive in quadrant 2. So let's see if this works. So sine of negative 135 is going to be the opposite of the sine of 135. So let's see. So we have the sine of 135. That is going to be the square root of 2 over 2. That's positive. But then negative 135 is going to be down here, and that's going to be negative. So it also works for angles other than like these acute and positive angles that we talked about.